Hello, sir. So in this video, we are going to be developing a model that is capable of predicting prices of cars using various characteristics, like the position of the engine, the speed of the car, and so many other characteristics that you can think of when it comes to cars. Our model will be predicting the price of the cars based on all these characteristics using machine learning. And we're also going to be training the model. Obviously, we'll train it, before it can predict, we'll be training it with some real life data that we are going to be getting from Microsoft repository of data sets. We're also going to be testing the model. So after training it, we'll be testing it with real life data as well to get to be sure that it is accurate and fully representative of what it's trying to depict. And this particular data set, even though it's tilted towards cars, you can always use follow the same steps for other type of data set, depends on your own particular use case. And we are going to be leveraging the machine learning studio in Azure for this. So let me share my screen. Hearing, um, yeah. So I believe you should be able to see my screen now. Okay, so I want to go to Azure. So the machine learning studio, ml.azure.com. So you can also do this from let me take this out. You can also do this from the portal. So by just searching for machine learning, Azure machine learning. You can do this from here as well. You can click to create a workspace and work with it or a registry. But I prefer to work directly from the studio. So there's a link to go to the studio from here as well after you've created it. So I'll give it a name. Let me call it I don't know. Um let me call it Mary. Let me call it Mary Caris. But let me just call it Caris Workspace. Okay. Caris Workspace, because this is a workspace. Then the hub, we are not adding it to an hub. If you want to know what an hub is, just click over here and you see what an hub means. Use hub for AI Foundry. Then we have this resource group. This is fine. I don't need to create a new one. EastUS2 is also fine. Let me create. So all I'm doing here is I'm creating a workspace that I want to work. I want to put all my machine learning resources on. This is loading. This is loading. Yeah. So another thing is that while this loads, our data set is going to require some transformation before we can actually use it. So it's a real life data set. So that's something that you always a skill that you need, being able to transform data to the structure that you want to work with it. So we are going to do some transformation. Just have that in mind. So we've created okay, still creating. Still creating. Let me scroll up. Uh, Scroll up. Yeah, still creating, still creating. So we'll be doing some transformation. Um, we'll be trying to remove empty data. We'll be normalizing our data set, some fields in our data sets, and so on. We'll be doing all that. Okay, so our hub, our workspace rather, has been created. So we can click on workspaces, and we can see our workspace. It's been created already. Okay, so click on this. We want to open our workspace, and it's open. This is where our action will come into play. So I will go over to compute because we need something like an operating system, compute resources to be able to run our machine learning. So we are not working with compute instance, rather we are working with compute clusters. Okay. Then scroll over here. We want to create a new compute cluster. So this is our infrastructure. And the reason why I always prefer using clusters rather than compute instances that is because of the auto scalability that comes with cluster. Okay, so we leave dedicated CPU. I scroll down. Um, Let me pick this. Memory optimize is way cheaper. So I think I'm good with that. Okay, so next. Over here, minimum number of nodes. So this is where the action really happens. So node is just like the amount of virtual machine that will be running at a time. And we want it to downscale to 0 if it's not active. So if I should click on this, minimum number of nodes that you want to provision. If you want it again, number of nodes, set that count here. So the minimum can be 0 if it's not active. Then the maximum we can put 2 idle second before scaling down. So it can scale down to 0 number of nodes. Okay. We won't be using SSH, so I don't need to set that. We don't need to set tags as well. Okay, so why is it not created? Um, okay, the compute name. So let's continue with carries compute. Carries compute. Okay. So now we can create our infrastructure that will be running our machine learning on. And our infrastructure is memory optimized. And you know, machine learning uses a lot of memory. So um, despite the fact it's memory optimized, we ensure that it is also quite cheap. Okay, so it's done now. So the next thing we need to do is we go over to designer. So this is where we design the architecture for the flow of our machine learning. We create our pipeline. So I click to create a new pipeline. Click to create a new pipeline. So there are a lot of data sets. If you come over here, sample data, you're going to see a lot of data sets here. If I extend this, and these are real life data. You can see census income data sets, animal images data sets, automobile, which will be what we are going to be using. So there are so many data sets here from different countries. We have IMDb's and the likes. And if you don't even want to use a sample data set, you can also add your own data sets as well. And at the end of this video, I'll be showing you how you can use your own data sets after testing your model. Yeah, so these are just some sample data, but what I'm interested in is the automobile one. So I'll just come over here to auto, and I can see the data set over here. So I drag it over here. Yeah, so this is my data sets. So if I should right click and come over to preview data, you can see the structure of the data. Yeah, you can see the structure of the data. You can see that this field normalized losses. You can see it has a lot of not a number as value, which is why we are going to be excluding these fields um, from our computation. You can see so many properties um, around a car. You can see fuel type. It can be gas, it can be diesel, um, it can be fuel, crude oil. So all these properties, we are going to be trying to use them to be able to predict the price, and we are going to be testing the accuracy of our model. Okay, so aspiration, number of doors, body type, length, width, height, engine type, and so on. So there are so many. We have about 205 real cars listed here and 26 columns. So 26 characteristics. Okay, so let me minimize this. Okay. I just wanted you to see um the content of the data set. So if you want to change you can see over here we have version 3. If I should double click this, you can change the version. So you can go to version 2 or version 1. I don't want to go to version 2, but depending on the version you want to work with, um, you can know the one you are interested in. Okay, so we also have a way of consuming as well. Yeah, so we are going to be coming back to this too as well. So let me just take this out. So now let's want to select columns in data sets. So I just drag it over here. Okay, so I can extend this because we want to select columns from this data set. Then I double click, then I edit, I click on by name. So I want to exclude these normalized losses because there were a lot of not in number. So I add all, then I remove normalized losses by clicking this subtraction symbol. Okay, so I have all the remaining, which are all the data sets that I want to be using. So the model will intelligently determine which of these fields contribute significantly to the price, and we just do all the computation. It's a lot of mathematical formulas. So I mean, um, I don't want to bore people that are not mathematics inclined with all of that for the formulas for linear regression and the likes, but the background to this, what this studio is doing for us, I mean, we are just doing it based on clicks. It's actually a lot of formulas, a lot of mathematics are happening behind the scene. So now after that, we want to do some cleaning. And as I said earlier on, this is an important part of um an important part of machine learning. So we want to clean missing data. So I drag this as well. So let me maximize my spaces, put this way, and I'll put this way down a little bit. Okay. So we want to clean missing data, but we want to link the selected column. And the reason why we excluded the normalized field is because I mean, it is normalized. It's not a real feature. It's a normalized value. We'll be seeing what normalization mean very soon. because we're also going to be doing some normalization in our data set as well. So I'll drag this over here. Yeah, so I want to clean missing data. So I'll double click on this. We are going to be cleaning some of our data sets. So I'll come to edit column. Okay, the first thing I will even do is let me change this to remove entire row. So anytime there is a missing data, I just want to delete the entire entry in our data set because missing data can have an impact to our model, a negative impact to it. So the columns that I want to clean, just give me a moment to fetch it out. So I want to clean ball stroke and horsepower. So I'll get the spelling correctly. I'll click on this with whose column names, ball, can use a comma, stroke, comma, horsepower. So all these are features in our features of a car, some of the characteristics, some of the um, parameters, part of the 25 parameters I want to use. So I click on plus so that it would automatically detect this. I can take this out. So we want to clean this. And the reason why we are cleaning this is because I have gone through the data set and these three columns add a lot of, these three fields add a lot of missing data. So we want to exclude those completely. We want to exclude those completely rather than allow it affect our data sets. So I've saved that and the cleaning mode, there are several modes here, but just I'm going with removing the entire row. So I am not removing the entire column because I still want to make use of um the what's it called? The feature for some other cars that makes a lot of sense. Okay, so let me minimize this. Clean missing data is now fine. The error is gone. I hope I'm recording myself. Let me confirm. I'm recording myself. Just give me a moment to confirm. Okay, yes, I'm recording myself. So let me share again. Okay, so I believe you can see my screen now. So after cleaning the missing data, we are doing some data transformation now. The next thing we need to do is we want to normalize the data. And this normalization is very, very important. It's a huge game changer because it ensures that we do not give undue weight to some fields and while ignoring some other fields. It tries to balance the scaling among our fields. Okay, so what I will do is for you to understand normalization better, I'll just go over to meta.ai and we'll just see what is the significance of normalization of data. What is the significance of normalization of a data set in machine learning so that you can see it yourself? Yeah. So it's really, really important, very, very important. Better model performance, yeah, blah, 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 blah. You can read this and explore normalization more. As I said, it's very, very important. Take note of it. Okay, so what we are going to do is I would come over. This is the clean data set. This is this is for cleaning transformation. Okay. But the clean data set is what I'm interested in. So I will take this up and I'll link it to our normalization here. Okay. Note, don't take this. We're not doing this. You're not dragging clean transformation. We're interested in the clean data set after we've performed this operation, this particular operation. So now you can see there's still a warning here because we've not selected the field we want to normalize. So I double click here, and there are different transformation methods when it comes to normalization. But in our case, I'm working with min max. You can see the z-score and the likes. So I'll click on min max, and now I want to select the columns I want to normalize. So I mean, when you want to normalize, there are some columns that normalization fits in, because normalization is a highly numerical operation. So you can normalize some categorical data set, you can normalize numerical data set, but it wouldn't make sense if you are normalizing a nominal field, a nominal variable. Yeah, so basically, let me fetch the columns. About 14 columns out of our 25 are what we are going to be normalizing. So let me fetch them. Just give me a moment. Count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, we have 13 here. I think it's about 13. I hope I'm not skipping anyone. So 14. This is 14. Why do I feel like I'm skipping some as well? So let me just go with what I have. So I click on add. Sorry. If we get any error, we are going to debug it. So when we run our pipeline, we'll debug it. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, it's 14, not 13. So I hope everything is spelled correctly. Okay, so now let's save. Yeah, so we are good. The only thing you need to change is transformation method. You leave U0. So we are normalizing to values between 0 and 1. Okay. So we leave this. Yeah, so basically we've been able to do that. We're going to be running our pipeline very, very soon. So what I want to do now is, after that, we now want to submit and configure and see the value we are going to get from our pipeline. Okay, so let me go back here, and I hope I am not forgetting anything. Hopefully I'm not. So I click on configure and submit. So are we selecting an existing experiment, or we are creating a new one? Since this is the first time we are running this pipeline, we want to submit it. We are submitting the pipeline job. We click on create new. Then we give it a name. So I'll call it carries experiment. Okay. So job display name, we are fine with this. The default, because this is just a test, we don't need tags for now. So I click on next. Don't need to add inputs and outputs. We are going to be doing that later on. Now we need to choose our compute type, which is compute cluster. Now we need to select our Azure Machine Learning Compute Cluster. We already have one created. That was what we created when we went over to compute. You can see it's over here. Click. Then our data store, we can work with the workspace blob store. We are fine with that. So everything is good. Continue on step failure. That's fine. Click on next. So I think we can submit now. Hopefully everything will work well. So let me click submit. Okay, so it's been submitted now. You can see the information. We can monitor the job by clicking on this view details over here. I'm hopeful that everything will work well. Yeah, so it's going to start from here. It has selected this data set, then it goes over to selecting columns in data sets. So it's going to exclude the normalized what's it called? There was a field that was normalized. So it's going to exclude that at this step. So it's still here now. It's trying to run this operation. So we just need to wait. I do not want to pause the video, so I'd rather wait for it to finish so that you will see everything in real time. So as I said earlier, data transformation is very key. If you don't know how to transform data, your model and your ability to be a data scientist and use machine learning can be an issue. Because I mean, without this data transformation that we are doing, if I should test the model without data transformation, you're going to see that the accuracy will be greatly affected. Okay, so this is still loading. I can refresh as well. Yeah, it is done loading. Now it is running it. It is running it now. As for this field, it's extracting all the data into the results data sets. When this step is done, it will move over here. Gonna be done soon. It won't take, I think the last time I did it, it took less than 5 minutes for the pipeline, so 5, 10 minutes. So the whole aim of this video is that if you need to demonstrate machine learning capabilities at a very high level, practical machine learning capabilities at a very high level, you should be able to run through this entire process. Another thing is that, I selected the compute resource, the infrastructure I selected is one of the cheapest that is memory optimized. So the better your compute resource, the infrastructure, the virtual machine, the better your pipeline is going to run. That's probably why it's also taking a while. Yeah, it's loading now. It's loading, it's loading. It's going to either display an error or it will be marked as completed very soon. Hopefully, it wouldn't display an error. Yeah, it's marked. So this is completed now. It's moving over to this step now. Yeah. For cleaning the data set, that's it was just three columns, so that shouldn't take time. So as I said, normalization ensures that no single variable dominates the predictive analysis just because of its scale. Essentially, normalizing your data means transforming the values of your features so they fall within similar range, and it helps our regression model as well. So it's great. And the reasons for normalization include sensitivity to the feature scale, improved convergence speed, prevention of numerical instability, and equal contribution of features. Okay. Yeah, so this is also done. We are in the normalization now. Yeah, it is completed and it's completed successfully. Hallelujah. So let's preview this. Let's preview this. So let me go to preview data. I want to preview the transform data set now. The first one is for transform data set. The second option here is the transformation function if we need to modify something. So I'm previewing the transform data set. I want you to see the normalized information. So you can see the columns that were normalized, they are all between 0 and 1. So instead of maybe a length, one length being 50, let's say 500 centimeter or something, another length being maybe 50 centimeter, which makes the gap quite wide, even though in terms of contribution to the predictive analysis, it shouldn't be so. Normalization puts everything between 0 and 1, which makes our model better. So you can see all the normalized, you can see engine type was not normalized because, I mean, it's a nominal variable. Okay, number of cylinders, you can see all what was normalized. Okay, so that's what normalization does. You can see our transformed data sets. Okay, so, and if I should open this, if I preview the data for select columns to select, you see that you're not going to find the column that I excluded here as well. But because of our time, let's just move ahead. So let me come back here. So what I want to do now is very simple. So we've been able to run our model, but there's something I want us to do. Let me reduce the zoom so that I can add more components over here. Take this here. Let me take this here. Yeah, so I have space to add more components. What I want to do now is that um we have a group of data sets. Before I actually before we really kind of like test our model before we train our model rather. I want us to split our data set into two, 70% for training, 30% for testing. So I will search for split here. I'll set for split data here. I'll bring it up over here. Yeah. Note that the only thing we've done so far was to transform our data sets before we can actually build our model. But I do not want to use the entire data set to build our model. I want to use a portion of it, 70% of it to build our model. The remaining 30%, I want to use it to test the built model to confirm its accuracy. You know that the data set is a real life data set. So the 30% will be for testing. So what I would do is under the split data set, which I have here, I'll come over here. I will drag this over here to data sets. Okay. So I would double click on this split data. Then by default, it's on 50%, but I'll change this to 70% because I just need 30% for testing. Okay. So randomize split two, which is fine. So the 70% should be random. It shouldn't be like the first 70% and the last 30% to reduce bias. Then the random seed is being done randomly. So we can enter any value as the random seed. I can enter 1 to 3 because I mean it's not a big deal. So I can do that. Certify split. No, I don't need all that. So what I would do is I will just minimize this. So this makes a lot of sense. So we are splitting the rows, not column, not any other thing. We are splitting rows because rows is what our data set is. So I think we are good. So let me close this. So this is for the splitting. So 70%. You can see we have data set 1 and data set 2. Okay, so this makes a lot of sense. So after splitting, what I want to be able to do is I want to be able to train our model. So before we actually create our regression, our linear regression components, what we are going to be doing is we want to bring train model components into our canvas. Okay, so I would search for train model. Yeah, I would bring it to my canvas. I'll bring it here. Okay, so what I will be doing now is I want to train the model with the the with a portion of my data set, not everything. So I would take this, the first data set, the 70% that I want to use, and I would take it over to the data set here. Okay, yeah, so I'll take it over there because I want to train the data set. Then another thing we are also going to do is I will ensure that I want to train the model on price because price is our predictive variable. So I would double click on this. I would go to edit column, take this out. Then I would include price here because price is what I want to predict. Now save. Okay, so this makes sense. Okay, so we have price here. So after training the model, um, we also need to confirm what we want to use the kind of model we are interested in, and which is linear regression. So I don't want to get so mathematical on what linear regression imply, your scatter plots, how you draw a line of best fits and things around that. But that's what Azure is doing for us. It's doing everything in the background. Okay, so I would search for linear regression because we want to train the model using linear regression. Regression. I would bring it out. What do you hear? And I scroll down. Let me take it here. I can scroll here. Okay. Okay. So we have linear regression here. Okay. So we have linear regression. So what I'll be doing is I want to link linear regression the with our train model. Okay. Take this out. Okay, let me move it here because I'm moving from the train model. We take this out again. Okay, so I think all I need to do is let me take it. Yeah, I need to take this down. Yeah. Okay, so give me a moment to just have my architecture on point. Okay, so let me share my screen again. I just needed to um have a closer look at my canvas. So I'm sharing my screen. We are still trying to architect. We've already done all the data transformation. We are trying to train our model using linear regression. So I would share now. Okay, so we have this. This was where we stopped from the last video. So what I'll be doing now is from our linear regression, which we have over here, I'll move this over here. Then the untrained model from here, take it down here. Okay. So let me take this up a little bit so that it will look good. I should rather take this down. I don't like my arrows to be crossing the components. Okay, so we have this now. I think this makes sense. So the next thing we will be doing is we need to have a means to evaluate our model. But before doing that, we are going to be adding a score model. And the score model is so that we can see the actual price and the prices that the model predicted. So we'll be picking this up and I'll be putting it here. Yeah, let me put it here. So what we are going to do with this score model, putting it here. So for the score model, we are going to be connecting the output of the train model into its first inputs. So take this, the train model, into the first input for the score model. Okay. Then afterwards, as I said earlier, we need to evaluate our model. So we'll be bringing in another component again. And this time around, we'll be bringing evaluate model. But before we even do that, we are going to be connecting the second output in splits into the second input of the score model. So I'll be going over here, the second output in splits. Here's our splits. It's here. Take these. So we want to have the untrained model. When we are testing our model, what's wrong with my mouse now? I don't know what's happening to my mouse. Okay. Oh, I think let me just use my keyboard. Putting this over here. Yeah, this is not good. We need to, I don't like arrows crossing each other. Yeah, I think it's better now. Okay, so it's better now. Okay, so that is that, by the way. As I said, we are going to evaluate. So what we are doing is, for this score model, as I said, we want to be able to compare the actual prices and the price that the model predicts for the when we are testing our model. So the next thing we need to do is that so we can decide to do the evaluation now, but I would rather, let's see, we've done a lot here, so let's try to run it and see if it works. Then if there are no errors, then we'll do the evaluation model so that we can be able to see um the relative standard error, RSC of our model, which is what will tell us if our model, how accurate our model is. So with this now, I can configure to submit again. I hope I'm not forgetting anything. Let me try to double click this. There's nothing here, so we are good. Train model, I already added price, I think. I already added price. Linear regression, we don't need to do anything here. So let me configure and submit. Um, yeah, so we are using the existing experiment, so we just need to submit. And another pipeline job will be in progress. This is the first one. This one was completed. We are running another one now. So we are going to click to see details very soon and follow up on it. Oh. So you can see it's not starting from the beginning completely. It's intelligent enough to know where to just go to. So it's splitting it now into dataset 1 and dataset 2. Dataset 1 will be used to train the model, dataset 2 will be used to test the model. That's why our dataset 2 was moved to the score model, but dataset 1 moved to training the model, and linear regression was coming into it. So I know it's a lot of components, it's a lot of arrows, but if you take it one after the other, sometimes I get a little bit confused on the flow, the actual flow. But the more you work with it, the more things will get clearer. So it's splitting it now into two, 70% for training the model, 30% for testing the model. Let's give this some time. You know. So when we are done with this, we'll now try to calculate the accuracy of our model. Because although even from the values, looking at the prices, the actual price and the prices that were predicted, you can easily know a model that you can know a model that is making sense and the one that is not making sense. But it's always better to use a mathematical formula because as humans, we can make mistakes. When you're using a mathematical formula, following a standard, it's easier to know what's making sense and what is not. Yeah, so it's done loading. It's about to run it now. Split model. Because it's splitting, that's why this is taking some time. So, okay, so already running now. Running now. It should be done now. It's either we see an error or it goes to, yeah, it's successfully splitted. So with this, it will come over here first. To come over here first, I think. Let me see. Okay, to come to linear regression first, because this is using linear regression as an input. Linear regression is an input over here. So this cannot run without this linear regression. So this is done. And now um this can start. It's an input. Let me make it, let me zoom out so that we can see what's happening clearly. Now it's training the model using the splitted data, the 70% from it. It's done training it now. It's now going to use the score model to allow us to test the model. She's using this to test it. So the 30% and the trained model and the 30% I want to use to test it. That's what's happening here now. Yeah, this is completed without any error. So we are good. So we've been able to do all this. So just for us to confirm, if I should come over here and I go to preview data, uh, scored data sheets. Yeah, you're going to see a scored data sheet here. But what I'm even interested in is we have our scored labels, we have our prices. Under the prices, prices are the actual price. Score labels are what our model is predicting. You can see over here 9233, we're having 8 here. When it increases to 14, here it increases to 16. So you can see some consistency around what the model is predicting and the actual values over here. Okay. So I mean, it's a model, so it can't be 100% accurate, but there should be consistency in its values, and to a large extent, we need to be sure that it is giving sensible results. So you can scroll down and see everything here. You can see we have 60 rows over here. Scroll down. Okay, so we have 60 rows because we've cleaned up the model. Recall that we said that anyone that the missing values that fell within a particular ratio, we remove the entire row. So all that were removed, as well as the 70%. That's why it goes down to 60. Okay, so let me minimize this. So what we now want to do is to evaluate the model. We want to use some mathematical formulas to confirm if our model is making sense or if it is not. So I go back to my designer and I go to evaluate model. I go to evaluate model. Let me create some space for myself and I bring in evaluate model over here, make it a little bigger. And what I need to do now is to drag this called data, um, this called data sheet. I'll be dragging the first output, the output of the score data sheet into the first input of the evaluate model. So I need to drag this. Let me increase so that it will be clearer for me. Into, yeah, my mouse is messing up. Yeah, let me make it smaller. Okay, so this is what we need to do. And we are going to run our pipeline again, and so that we can see the values. So let's configure and submit one more time using the existing configuration settings, and we submit. This is the third one. The third one. This was the first. This was the second, and we're about to click to see the third one. Yeah. So this is the third one, third pipeline. So let me scroll down because I'm really interested in the evaluate. It's already running. Yeah, the evaluate is already running. So that's what we want to see. So it's performing some mathematical calculations now to determine if the model makes sense or not. So while that is opening, let me go to Gemini. Should I use Gemini? Let's use DeepSeek. Why are you asking me to sign it? I don't want to sign. Okay, so let's use Gemini. Let me go back to my model. Is evaluation completed or is still running? Still running. When this is done, a couple of things I want us to see when it comes to evaluating our model. So one thing I will also I didn't mention is that in addition to using raw data sets, we're also going to see how we can um, send data into our model using an API. So we can send data to it. So we can any kind of data, not data from any official data sets. So we are going to tweak our pipeline in such a way that we can have data. So I can send any type of features and their value, any group of characteristic of a car into the model for it to process. So that way we can our model is highly customizable. And we're also going to be seeing how we can write programs, very basic programs that connect to this API and is able to provide responses. The response in this instance is the price of the model, the price of the car. Just going to make some little modification to what we have for you to be able to accept raw data instead of data sets. Well, raw data is still data sets, but let me say instead of the data sets from Microsoft. Yeah, it's done loading. It's now about to run. It's in our model. I think I should probably have used a better computer, like a better infrastructure, so that in subsequent machine learning videos, I will use the specification of the computer I'll be using will be a lot better, so that that can help with the performance, so that it will be faster. Because machine learning is a lot, it's a lot, and you need to have very good operating system to be able to work with it. Yeah, it's done. It's completed now. So now what I want to do is I will right click on evaluate model, go to preview data. You can also access the data if you want to download the output, but I just want to preview evaluation results. Yeah, so this is the interesting part. You can see many formulas and their value. Mean absolute error, root mean squared error, relative squared error, relative absolute error, blah, blah, blah. But all these have their interpretation. All these, they have rules governing them. So there are some that if they are closer to one, it's a good thing. Some, if they are less closer to zero, it's a good thing. So, and that's why I opened Gemini. So you can check all of this using AI and research on the internet. But the one that I am quite familiar with, as a matter of fact, I've done a lot of this, but many years ago. But the one that is still kind of fresh in my head is a relative squared error, which is RSE. And our value is 0.08. So what we'll do is I will ask Gemini, um, how do I interpret relative squared error value in um, linear regression? Yeah, this is the formula interpretation. If it's equal to zero, this indicates a perfect fit, which is not possible. Yeah, you can see it is rare in practice. Then if it is between, it's always, this is where it's always, but the closer the RSC is to zero, the better your model fits. So you can see our model here, sorry, our model here, our RLC is 0.08, which means our model is a good fit, right? Okay, so that's basically it. Yeah, yeah. Okay. So that is that. So in the next video I'll be creating, I'll be showing you how we can modify this our pipeline to be able to accept what to be able to work as an API. So we want to have an API that would send some values, some parameters to that API and their values. Then the API will respond with the price of the car. That's what we're going to be doing in the next video. Okay. So right now, we want to be able to enter data manually using a web service. We want to be able to use your web service to enter data as inputs as well as a web service output. So what I'll be doing, you know that in our initial pipeline, for this pipeline, we are entering data through this data set, this Microsoft data set. So we are going to need to delete all of this. So we'll be taking it one step at a time. First thing I need to do is to delete this. So I come over here, I so even before I delete, let me add my real-time influential pipeline. So I'll come here, let me go over here, do it from here. Create influence pipeline, then real-time influence pipeline. In the latest one, so that's the one um with evaluation model. Okay, I'll come over here, create influence pipeline, create real-time influence pipeline, and I'll click. Yeah, so it's been created now. Yeah, so we can see that our web service inputs and web service outputs have been added to our pipeline. So what I will do now is I'll be deleting this. So I will delete because we are not using that anymore. We want to enter our data ourselves. Okay, so let me see. Yeah, so we are going to search for a new component now. A component enter data manually because we want to enter our data manually, obviously. Yeah, enter data manually. The we use this to replace the what we had previously. So I'll take this and connect it to this. My mouse, please. Oh, what's this? My mouse is messing up. Okay, so we have this now. Okay, so we need to double click this and do some modifications to it. So I'll be entering some data that I have from that university site that I showed you earlier on. Where is it? Yeah, so I downloaded this and I took some data from it, which is what I'll be pasting right now. So just give me a moment to fetch it out. Okay, so I've gotten it. I'll put it in. Yeah, So the header, this is the header CSV, makes sense. Notice that we do not have price here. We do not have price here. There are no prices. Oh, and there are no prices. Okay. And it's a CSV file, so I'm fine with that. So let me minimize that. Okay. So the next thing we need to do now is we have to ensure that what we have is in our select columns in data sets. We need to remove price from that because price is not in our data set. So we are not, and besides, we aren't testing the model, we are using it. Okay. So for select columns, we need to remove price. So remember that this was what we the annotated, the normalized labels or something. This was what we used to exclude it. If I should go over to this enter data manually, you can see the normalized losses rather. So we are excluding it from 2 years. Then we are also removing price because we are not testing, we are not training the model. We are using it. Okay. So the next thing we have to do is our evaluate model. We are no longer evaluating it because we've already evaluated it. So we need to delete evaluate model components because we do not need it anymore as well. We also work on our score model. So I will scroll down. Oh, okay. So I'll scroll down. Where's our evaluate model? Yeah, our evaluate model. Deleting this. Deleting it. Okay. So our score model, we have to make some modifications to our score model. And the reason is because we want it to fit our use case. And we'll be using a custom Python script for this. So we'll be adding execute a Python component. We are going to be adding execute a Python component, and we are going to be connecting it to our scored data outputs. So I'll search here for execute Python scripts. I'll bring it out here. And what we'll be doing is we'll be connecting it to our scored model. Okay. So I would take our output from the scored model into the data set for execution of the Python script. Yeah. Then let me reduce this. I will double click here and modify this. So essentially, I will just delete everything we have here and paste a, a very simple Python code. Just give me a moment to fetch it. Okay. Yeah. So we have our Python code. Then our web service also needs to be moved. Take this down. These arrows can be very sometimes the way they move, I don't know. So our web service, we're also going to modify the arrows around it because we want to connect it to our Python script because the Python script is interacting directly with it. So we're going to be connecting the first output for the Python script into the input of the web service. So this first output for the Python script, we're going to be connecting it as inputs into the web service. Let me take this out. Okay. Yeah, so I think this is good. I think we can save now. If there's any error, we'll rectify it. But I think we are good. 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 Okay. Web service output. Um, enter data manually. We convert to data sets before selecting columns that we want to use in data sets and our as a web service input. Yeah, so I think we are good. I think we are good. I think we are good. I think I can submit this. If we have any error, we are going to debug it together. The first time I was working on this particular tutorial, I had a lot of errors. So I was fixing it before it finally ran. So errors are part of it. Are we creating a new experiment? No, we are using the existing one. The existing one. Yeah, this is good. So I can run. So I hope you understand what we are doing. That's the most important thing. So I'm running this now. I'll walk us through all what we are doing. I will explain it again so that would really, really have a clear understanding on what is happening. So let me view details so that we can see the flow to be sure everything is working well. So we are here. Let's see the content of the convert to data sets. There's nothing there, so it's fine. So just be patient with me. Let's have this one and hopefully it will work as expected. One thing I'll say is that I'll be creating a GitHub repository for this particular project, and in that repository, I'll be including all the code. So in terms of the variable names, because one issue I was having was that I was misspelling some variable names because I'm not familiar with all these parts of a car. So I would be having all of that in the repository that contains all these variables so that you can pick it up and choose copy and paste. Then also the Python code will be in the repository. I will also be including the data set that we used, the 3 rows that we used. So it's done now. It's trying to run the enter data manually now with the data that we have. So the repository, we have all the resources that is in use in this entire project so that you can confirm that you are spelling things well. So as you know, the aim of this session is we want to convert this to an API. We want to be able to write a program from an independent program, send an API request with um, the car features, and we want the API to respond with the price of the car. So that's essentially what we intend on doing. Yeah, so this is done. Starting this now. Converting to data sets. This is not even important because there are no operation there. So I can choose to delete this and just connect this directly to select column in datasets. Yeah, this is done. So it will come to web service input now. Rather, it will come here before going to um, the web service input. We feed it as an input into here. So the web service input is feeding into it. Yeah, this is done. It's coming here now. Just be patient, be patient. A lot of people, a lot of videos, people will pause the video and when everything is marked, they will just come back. But I don't like that approach. I want it to load in real time so that you see how everything is happening. Yeah, this is done as well. Let me go down. Moving. Okay. My mouse it has been acting really funny. I don't know why. Okay, score model is done to finally. We're executing the Python script now. Hopefully, I didn't make any error when I was copying the Python script. Yeah, Python is done. So now the web service output. Yeah, I think everything is done. I think everything is done. So it's completed successfully. So we've been able to do this. So one thing we are going to do is let's come to the Python script because the reason we created the Python script is for us to be able to format our data properly and based on the structure of our entered data sets. So let's go to result data sets and we're going to see the prices, the predicted prices. So you can see the predicted prices of the three um, categories of cars. You can see there are three here. If I should come over to where we had enter data manually and I go to preview data, you are going to see them here too, the three of them. I'm going to have it here as well. Okay, so let me close this. Now, this is the interesting part. We now want to deploy this pipeline. I want to deploy it into either a Kubernetes cluster um, or a container instance. So to deploy it, what I need to do is, where's deploy? Where's deploy? Come over here, click on deploy. We click on deploy. We give it a name. So let's call it carries deploy. We change the compute type from a from Azure Kubernetes service to container instance. And let me see what we have in advanced. It is fine. I don't need to enable SSL. So we click on deploy and the deployment will start. So we are deploying this our pipeline into a container instance. So that's being done now so that we can access it via an API. That's going to take some time. That's going to take some time. So I think we can just end it here. Then in the next, no, I don't want to end it. Should we end it? I think we might need to end it here. Then in the next video, I'll just show you how you can write a program to access it, or how you can also use the studio to access the API. Okay, so we've been able to deploy our pipeline into a container instance. However, we're waiting for it to be done loading. Let me confirm that it is done loading. I'm running Visual Studio at the same time, so my computer is kind of sluggish right now. I need to close this. Be patient with my code. Yeah, so this was where we were. You can see now it says that the deployment of carries deploy is completed. The job is also completed as well. So all we need to do is we come over here, we click on deploy details, or we can even just navigate here to endpoints. Click on endpoints, and we'll see our endpoint here, our real-time endpoint, carries deploy. You can also go to Azure Container Instance to see the VM that is running. So now I will click on this. I'll click on this. I can see the details of our deploy. We can test it from the Machine Learning Studio over here, but because the API I'm using is version 1, we can't do that here. So we'll have to write a code to work with it. So we can consume it. So I would have worked on the API, changed the API version, and could have easily used it here. But um, most of the time, you wouldn't want to do it from here. You rather have built application that you want to leverage on machine learning. So it's even good that we are writing a program for this. So you can see that we have um, boilerplate code for Python, C Sharp, and R. Because I've been doing a lot of C Sharp lately, so I will stick to my C Sharp. Yeah, I'll be sticking to my C Sharp, and what I'll just be doing is this is my REST endpoint. This is the primary key and the secondary key, which I'll be using. I'll just copy this code, the code we have here. I copied it. I copied this code, and I would be going to Visual Studio. Let me stop sharing. I'll be sharing my Visual Studio screen now. Let me add that. So on Visual Studio, this is a console application. Just create a new project, console application. Simple. Um, so come to file. My computer is really slow now. Apologies. New project, console application. That's what we are doing here. So I just created a new console application. I pasted the boilerplate code from Machine Learning Studio. Then the only thing I modified was for over here for my request URL, I just make it clear that I'm adding JSON content. So I added this content. I got this from so this can be anything. So from what when we said we're adding data manually, so instead of it being in CSV form, I'm now doing it from this code. So I added it, your normalized losses, instead of null, it can be a value. It doesn't matter because the field will not even be selected. So I added all this. I added two. Let me change this to 1.0 just for you to know that this can be anything. 1.0. Okay. So I'm adding two cars now. So this is the first car. I want to know the price based on all these parameters, the potential price. Then I just modified some fields. I copied this, I pasted it again, modified some fields so that it will definitely be a different price. So I added that. Then all these are the boilerplate code. Then I added the API key. This is the API key. I'll be deleting this video before I'll be deleting everything. My API key, I'll be disabling it before I push this to the internet. So you can't work on it. So I pasted the API key here from my Machine Learning Studio. So I think that's basically the changes that I made. That's basically the changes that I made, nothing else. Um, Yeah, that's basically it. So I'll be running it now. If everything works well, I should be having prizes. Price for this first car and price for this second car. And we'll be seeing the one that is more expensive. So our model, so it will be connecting to our machine learning studio on Azure, and it will be using the model that we have created, we have trained, we have tested to compute, to predict prices. So that's essentially what we are doing here. And these codes, I'll be making them available in our GitHub repository, so you can directly copy it and paste it as well. Okay, so let me run the program, and I'll be sharing the output screen very soon. So I'm running it now. I will stop sharing, and I want to share my output screen. The moment the output screen is up, Sharing my output screen. Yeah, so we are waiting to see the prices, the predicted prices. Sharing the output screen. So we now have an API that we can work with, and this can be from, although I don't have a front end here, but you can make it a front end, connect it to your ASP as a back end, and you'll be able to work with it as well. Okay, so you can see results. The results predicted price for the first one is $14.996. Predicted price for the second car is $13,670.611. So you can see that we are able to predict price and we are getting a JSON response from our program, and this is connected to our machine learning studio. So everything works well. Okay, so I hope this video is informative. I'll stop sharing now. And let me close this as well. Yeah. So I'll be providing a link to all the resources that I used in this video. The code, the link to get your data sets, University of California, the variable names and everything. You are going to have the Python code, everything will be in the GitHub repository. Okay? Yeah, so have a nice day.